Lesson 6.1, Ratios, Proportions, and the Geometric Mean. What is a ratio? A ratio is simply a comparison of two quantities. Usually those two quantities are things like a ratio of the amount of gasoline to oil that you mix to run a chainsaw or a tiller or something like that. It could be the ratio of flour to sugar in making some sort of cookies or something. We generally verbally say a ratio of A to B, whatever A and B are representing quantities. We write it symbolically either with a colon, A colon B, red, A to B, or we write it as a fraction, A over B. In fact, that's the reason we call rational numbers fractions rational numbers, is because a fraction is a ratio of two numbers. 2/3 means 2 to 3. Ratios should be written in simplest form, and this can be accomplished by writing the ratio as a fraction and then simplifying that fraction. If I have a rectangle has a length of 21 feet and a width of 14 feet, what is the ratio of width to length? Now I need to write it in the proper order, width first, then length. And when I do that, I get 14 feet to 21 feet. We change that into a fraction, and then we can simply reduce that fraction by canceling out the feet. 7 goes into 14 2 times and 21 3 times, so we have a ratio of 2 to 3. Note that the units do cancel out in a true ratio. If the units will not cancel out, like doing miles and hours, you can't change miles into hours or hours into miles, then that is called a rate rather than a ratio. In a ratio, the units of measure should always cancel out. If the ratio compares quantities with different units of measurements, then we need to try to make them the same if we can, and we do that with a conversion factor. For example, the ratio of length to width for a rectangle whose length is 30 inches and whose width is 2 feet. Well, when I write that, I have 30 inches compared to 2 feet. But what I need to do is get rid of those feet and inches. So I'm going to use a conversion factor. I know that 1 foot is equal to 12 inches, so I could write that as a ratio itself, 1 foot over 12 inches. Since those two are the same, I'm really got a fraction equal to 1. We know if I multiply the fraction we had, 30 inches over 2 feet, times a fraction that's equal to 1, then I should have equivalent fractions. Notice that what I did is I put the inches on, since I had inches over feet here, in my conversion factor I put feet over inches. That's so that the inches would cancel, the feet would cancel, and I would then have simply 30 over 24. All of my units of measurement cancel out, so it is a true ratio. Then I can reduce that to 5 over 4, which means my ratio of length to width is 5 to 4. Let's look at a couple more examples. If I've got 64 meters compared to 6 meters, or 64 meters to 6 meters, then what I would do is write it as a fraction, and my units would divide out, so I could simply reduce that fraction to be 32 over 3. So that is my ratio. For 5 feet over 20 inches, I need to use my conversion factor because feet will not cancel with inches. In this time, what I'm going to do is I'm going to write it where inches are on top and feet are on bottom, so that everything will cancel out. I get 60 over 20, or 3 over 1. So I have a ratio of 3 to 1 here. Simplifying this ratio. Guided practice is where you should try it first and then check to see if you got it right. So you may want to pause the video now and try doing this problem. 24 yards to 3 yards. Since the yards cancel out, I simply reduce it to 8 to 1. For 150 centimeters to 6 meters, I'm going to have to use a conversion factor there, which would be 1 meter to 100 centimeters. Notice that I have it where they'll cancel out. I get 150 to 600. And then I can reduce that as a ratio of 1 to 4. We've got a painting. You're hired to paint a mural on a rectangular wall. You're told that the area of the wall is 8,712 square feet. Remember how we get area? That's going to be length times width. And the ratio of the length and the width is 9:2. So find the length and width. Well, I know in the other problems when I had a ratio of 9:2, I have canceled out not only the units of measurement, but also some scale factor or the same number for top and bottom to reduce the fraction. So I can call the length side 9x and the width 2x, since they're in the ratio of 9:2. Now, I'll use my area formula. We know that it's multiplying length times width, so I simply solve this equation, find that x is 22, but it didn't ask me what x is, it asked me what the length and width are, so I need to substitute it back in. 9 times 22 is 198, 2 times 22 is 44, therefore the wall is 198 feet long and 44 feet wide. The measures of angles CDE are in the extended ratio of 2 to 3 to 5. Find the measure of these angles. Well, I've got my triangle drawn over there. I have plugged in that angle C is 2x, D is 3x, and E is 5x. We know that all the angles of a triangle must add up to be 180 degrees by the triangle sum theorem. That gives us 10x is 180, so x is 18. So I just need to plug back in. 2 times 18 gives me 36 degrees. 3 times 18 is 54 degrees. And 5 times 18 gives me 90 degrees for my 3 angles. The perimeter of a room is 48 feet. And the ratio of its length to its width is 7 to 5. Find the length and width of the room. This is another one where you may want to pause the video and give it a try before I work it for you. What I would do in this particular case is I would draw me the rectangular room and plug in that the length is 7x and the width is 5x. I know the perimeter is 48 feet, and I know that I get perimeter by adding up all the sides. That means this is 7x and that's 5x. So altogether I've got 24x equals that 48. X is 2, therefore the length is 14, the width is 10. For this one, it says a triangle's measures are in an extended ratio of 1 to 3 to 5, so I'll just draw me a triangle. I'll make one of them 1x, one of them 3x, one of them 5x. We know that they have to add up, meaning 9x has to be 180 degrees. In this case, x is 20, so when I plug in, I see that I have a 20-degree angle, a 60-degree angle, and a 100-degree angle. Now, proportion. What is a proportion? A proportion is when we set two ratios equal to one another. When we set this up, we would read that proportion A is to B as C is to D. The B and the C are called the means of the proportion. The A and the D are called the extremes of the proportion. Now, the key property of proportions is what's called the cross product property. What it means, you've probably heard it referred to as cross multiplying. So what it really means is that when I multiply the means together, it should equal the product of multiplying the extremes together. So if A is to B as C is to D, where obviously B and D are not 0, since we can't have 0 in the bottom of a rational number, then A times D would have to equal B times C. In terms of numbers, you can check to see that things are proportional. 2/3 is proportional to 4/6 because 3 times 4 is 12 and 2 times 6 is also 12. So to solve this proportion, what I would do is simply use my cross product rule, write the proportion, do the cross products. 5 times 16 is 10 times x, so 80 is 10x, and x is equal to 8. When I have one like this, I need to be very careful, because when I set up my cross product, I have to remember that the 1 is times 3y, but the 2 is times the entire y plus 1. So I have to use my distributive property there to get 2y plus 2. Then when I subtract, I can see that y is 2. So here's another one for you to try. So you may want to pause this video and try to work it, see if you get the right answer. When I do my cross product, I get that 5x equals 16. So dividing both sides by 5, I get 16 over 5. In this one, you've got to remember that 1 times 3x is 3x, but when I multiply my 4 times x minus 3, I'm going to have to distribute. That gives me 4x minus 12, and that's a simple equation to solve. You end up with x equals 12. In this one, we're looking at the same situation. 14 times y minus 3 is 14y minus 42. 7 times y is 7y, and you can simply solve that equation by subtracting 7y, then adding 42, then dividing by 7, and we see that y is 6. Let's look at a real-world application of a proportion type problem. As part of an environmental study, you need to estimate the number of trees in a 150-acre area. You count that there are 270 trees in 2 acres, and you feel like it's evenly distributed, so we can estimate the trees by setting up a proportion. All we need to do is say that 270 trees is to 2 acres, as how many trees is to 150 acres. So we do our cross product, and we solve and find out that there are approximately 20,250 trees in that 150-acre area. Now, geometric mean. All the other has been a review. I know that you've had proportions and ratios before. You may not have seen geometric mean. But the geometric mean is really a pretty simple concept. The geometric mean of 2 positive numbers, we'll call them A and B, is the positive number x that satisfies a proportion where the x is both of the means. So I have A is to x as x is to b. Now if I go ahead and solve this like it is rather than putting in numbers, I see that x squared is equal to a times b, so to get x by itself I take the square root. So my geometric mean by definition tells me that the geometric mean is equal to the square root of the product of the 2 numbers. So if I'm looking for the geometric mean of 24 and 48, I simply know that it's going to be the square root of the product. So the square root of 24 times 48. Now I'll simplify this by breaking 48 down into 24 times 2, which allows me to take a 24 out from under the square root sign, so I get 24 square roots of 2. If you want to, you can go ahead and estimate that. That would be 33.9 when you punch that into the calculator. So what if in example 5, suppose you count 390 trees in 3 acres. Of that 150 acre, how many trees would you have? Well, you could pause this and give it a try. You should come out with 19,500 trees. That is because if you do 390 is to 3 acres is equal to how many trees over 150 acres, then you do your cross product, you'll have your answer. Find the geometric mean of these 2 numbers. What I need to do is do the square root of 12 times 27. To find the geometric mean of 18 and 54, that's going to be the square root of 18 times 54, which comes out to be approximately 18 square roots of 3. And for 16 and 18, then the square root of 16 times 18, which is going to give you 12 square roots of 2. Now you can punch that. If you punched them into the calculator, you could check your answers here by punching that in and seeing if they are equivalent.